This is video number 3 in the exponent series about what happens when we raise an exponent to a power. So the next thing we want to look at is what happens when a power is raised to a power. So for example, we might have something like 7 to the third power and that raised to the second power. So the easiest way to understand the rule for this is to expand it out and show what it looks like. So if I take 7 to the third power, that means 7 times 7 times 7. And if I take that to the second power, that means multiply that thing, 7 to the third power, times itself. So I got two 7 to the third powers here. Now when I combine all these 7s, because with multiplication I can do that, I just put them all together. Get 1, 2, 3, 4, 5, 6, 7. So that would show that 7 to the third power to the second power is 7 to the sixth power. We can use another example with just variables. P to the second to the fourth would be P times P times itself 4 times. And that's going to be a lot of these variables. So here I have 4 groups of P times P, or P to the second power. And if I put that string of variables, those factors, all together, the base would be P, and I'd have 1, 2, 3, 4, 5, 6, 7, 8 of those. So my answer would be P to the 8th power. So this leads us to the general rule for raising a power to a power. So if I had a base of A to the m power, and I raised that all to a different power called n, then the answer would be A to the m times n power. So I keep the base and I multiply the powers. So when we had 7 to the third to the second, when we got 7 to the sixth, what we did is we kept the 7, kept the base, and rather than add these exponents, we multiplied them to get 7 to the sixth. And likewise, when we had P to the second to the fourth, our answer was P to the 8th. So I keep the base and I multiply the exponents when I'm raising a power to a power. That concludes video number 3. Video number 4 next would be dividing exponents.